Hello, I'm Mark, and welcome to part 2 of my Unreal Engine tutorials on how to add wings and flight control surfaces to your physics movement system. So in continuing with where we left off in part 1, let's do a quick little recap of our new systems. So first off, we created two. The first one we created was the flight physics surface configuration, flight surface configuration, right? So this is our rudders, ailerons, and elevators. And so in keeping with our kind of like our systems, we've got a way of finding them in the systems array. We also have whether we want it turned on or off. We have our mapping here, so we're using an enumerator to allow us to map the inputs as well as define the direction that we want our thrust or our force, I should say, to be applied through these control surfaces. And then we have our, as well as, do we need to negate that once we calculate it or not? And that's what the negation's there for. Again, location, since we're going to be doing force at points, so where we create a force, we're also going to be creating a torque value as well. And then also, we added all the variables needed to calculate that force and the direction that that force will be going in. And then, like always, we're putting in a condition percentage here, just in case we want to then start using create this as a degraded force. We have some public getters and setters, so we need to set the input control as well as the density of the medium that our system is going through, as well as the force that is going to be calculated and returned back to us. And then we have some internal functions here under private, which is just how we're going to be calculating our control surface forces. And these control surfaces are just how we want to turn a vehicle going through a medium. And then again, as well as some private variables we're using as part of the calculation. And then the second system was the wing stabilizer or the stabilizers. And so what we have is we have the concept of vertical stabilizers, which are wings, and then horizontals, which are our kind of like our fins on vehicles. And then we also created the concept of foil setups. So we could technically have multiple setups in a wing. So this would allow us to kind of have different profiles, and we can then switch between the profiles. So this would be flaps up, flaps down, or it could be variable geometry wings of an aircraft. If we wanted to kind of mimic that, we could do that through the setups. And then we have the physics foil configuration, very similar to to the flight control surfaces. The only difference is this doesn't have any moving parts. Instead, we just move between the setups. And so I just wanted to break these out into two separate things because I felt that they do work differently, even though they kind of use the same calculations. They are, one is for lift, where the other one is really for turning. This is lift and stabilization, where the other one is kind of like turning and controlling. So, all right, so that should do it for everything that we've done in for Visual Studio. So everything else that we're going to do here is going to be in the blueprint as we set things up, so that we can then go ahead and add this into a vehicle so we can play with it. So I'm just going to go ahead and minimize Visual Studio real quick and bring up the editor. And again, we'll do a quick compile, make sure everything looks good. All right, good. Compiled fine without crashing. That's always a good sign. All right, so I'm going to be, for this tutorial, I'm going to be using this fighter jet that I found in the Fab store. The price is right, free. And I'll leave a link to it in the description below if you're interested in following along. There are other aircraft in there too, and the system will work on them as well. So if you're not really into Eurofighters but want to do something else, have at it. But this is the one that I'm going to be using for this demo purpose. So, all right, so I'm going to just move this off real quick, and let's get started with setting this plane up. So once you if you're going to go through the Fab Store and grab something like that, you can grab it, you can download it, and once it's downloaded, it should put it into a folder under your content folder, which is the Vigilant content. And if you go into vehicles, you should see it there. It's very similar to the way we did it for the helicopter. you may get a warning saying, hey, you've got some duplicate files in there. And so, you see this shared folder. And that's what it's probably talking about. It's got these shared particles and shared vehicles information. Just say yes, go ahead and overwrite it. It's the same stuff. Shouldn't be a problem. All right, so let's get started. So the first place I like to start is going to be on the inputs. So I'm going to start there. So for our aircraft, it's going to be very similar to our helicopters and our drones. So I'm just going to go ahead and just duplicate the drone real quick. And I'm just going to call this plane. Actually, I'm going to call it jet. So IMC jet. I'm going to open her up real quick. So, so as far as pitch and roll, I am going to keep these. Let me just check with my other system real quick to make sure that there's no differences. Oh, so on pitch, we have a negate here. So I'm just going to go ahead and delete the negate. So I don't want that. We have the dead zone. Again, if you're not familiar with dead zone, when you're working with analog controls, you want to use a dead zone. Otherwise, because even if the player is technically off the analog, there could be very, 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 very minute pieces of data being transmitted, and that will actually affect your vehicle. It would be like 0.001 instead of 0. So what this is doing, it's saying anything under 0.2, treat it as a 0. Otherwise, from 0.2 to 1, take the value. So, and I think that's good for dead zone. All right, so I'm just gonna. So we took the modifier for negate off, since we don't need it there. We'll take it as is. Let me check roll, make sure that there's nothing special on roll. No, roll's fine. Again, it's analog, so we've got a dead zone there. All right, for yaw, I'm going to do something a little different for yaw. So I've got my controller and it's powered up. So for the yaw system, I'm actually going to use the left control stick for left and right. Since I don't, since it's got that 60-degree arc, I think that's really, putting it on a digital really kind of whips your plane around, can have the potential to whip your plane around a little too much. So I'm just going to go ahead and remap this to remap my, this throttle Z, this yaw. So what I'm going to do is I'm going to just remove the right shoulder pad here, since I only want one of these, and I'm just going to go ahead and set this to my left thumbstick on the x-axis. So all I did was I just clicked on the keypad, and then on a powered up controller I just went left on the left thumbstick, and it recorded it for me on the x-axis. And let me take a look at the inputs. Nope, we're good. The only thing we need to do here is, instead of negate, I'm going to just set this up to dead zone instead. So there's no negation. This will handle both left and right input. We just need to have a dead zone there since it's analog. All right, so that's pitch, roll, and yaw. Throttle, I'm going to change the throttle. I'm going to keep the gamepad for the throttle. I'm just going to remap this to the X instead, since I want to be, it just makes, for me, I could keep it on Z and then have Z go to X, but for me, I'm just going to map it to the X and just make it simple. But again, nothing's changed here. No modifiers on going up, on throttling up. We just have a modifier on throttling down to make sure it's going in reverse. And that's it. All right, so that's pitch, roll, yaw, that's throttle. So the only other thing we need now is to be able to get our flaps up and down. So to do that, we're going to need another action input. So input action. So to do that, I'm just going to come down to our actions. I'm going to right click in the folder and go to inputs. Go to input action, and I'm just going to say IA. Call it IA flaps. And this can stay a digital bool, bool. So we'll just keep that there. And under jet, I'm going to come back. I'm just going to close this so there's nothing else there. I'm just going to go ahead and add that mapping. And I'm just going to call it flaps. And I'm going to come back to my keypad or gamepad. I'm going to click on the keyboard and I'm going to hit my Y button on my controller, and that's going to map to the game face button on the top, and that's on the right side. All right, and let me just do a quick little check. And I am going to put a trigger modifier in here, and I'm going to set this trigger modifier to press. So this is going to pretty much say that this is a button, this is a press button, and it's just going to register the trigger on the press. So when I press it, it will then activate it, and we'll activate it for once. And I'm just going to go with a regular tolerance of 0.5. So not doing anything special there. All right, so that should be it for our inputs. So that's pitch, roll, yaw, throttle up, and flaps. So let's hit save. So that's our jet. All right, so next let's go ahead and go to our vehicle, and we just need to do some setup here. So I'm going to be doing all of my setup in the physics asset. So skeletals have physics assets, so we want to, and this is where it handles all the collision stuff if you're going to be using, especially if you're going to be using the physics asset as a physics body. So I'm just going to right click on the physics asset, and I'm just going to say duplicate since I don't want to actually alter the actual asset, and I'm just going to go sim. And then off here, let's just open this up. So we need to make a couple of changes here since we're going to be using simulated versus kinematic. So this whole thing was really, this whole asset was designed more for animation. And so it's using kinematic as its physics type. We want to switch it over to use simulated for our system. So to do that, we need to make a couple of changes. So since I want the animations to work, and the way that the person who set this up went about setting up the collisions, I found that the elevator for the left and the right, if the way it's set up right now, if I use it and set it up to simulation, it's going to make these things like droop, pretty much ragdoll out. So I'm actually going to go ahead and just remove these. So there's not much, the kind of like the fuselage kind of covers it a lot anyway. So it'll be good enough for what we're trying to do. There is a way that you can try and prevent it from ragdolling, but you'd need to go into the animation blueprint. And from what I'm looking at, you might need to use a custom animation blueprint, because what's going to happen is when we turn this to simulated, if those constraints were on, it would ragdoll those planes out, and then we would actually have to reset them on each frame to try and fight the gravity. So gravity is going to ragdoll them, and we would need to then fight gravity to get them back into the right position. And to do that, that's literally a whole video in itself. So for now, we're just going to keep this very simple. I'm going to take all the other stuff, and what I'm going to do is I'm actually going to go ahead and highlight the constraints, and then over here I'm actually going to go over to the angular limits, and I'm just going to lock them all for now. Ideally, if you want things to be moving, you probably want to set them to free, but again, you'd need to then use the animation engine to kind of keep them locked. But like I said, we're focusing on flight, so I'm just going to lock these for now. All right, so that should do it for our physics. The only other thing we need to do is to go up here, and on the C joint, I'm just going to move this to simulated. And so what's going to happen is everything up here, everything down here will then inherit or should inherit from simulated. If it isn't, I'm just going to set this to default. So what's going to happen is this is simulated. These are all going to should inherit from the simulated. So let me just double check. Yep. All right, so that's the brake hook, front chassis. That's the canopy. And then that's the undercarriage. So I'm not going to be animating the undercarriage again because of the collision stuff. So we're just going to keep the undercarriage out in this tutorial. I'm really not going to go too much into this more than I need. All right, so that's the physics system. You know, I'm just going to switch these over to simulate as well. Might as well. It's not going to hurt anything. So everything is now set to simulated. Everything's on simulated, and all of our constraints should be locked, so they don't ragdoll. Yep. All right, cool. So that should do it for that. So the only thing I need now left is to go into the skeletal and go to asset details and just switch over so that it's using our physics asset with the changes that we made. All right, so that should do it for the changes to the aircraft. I'm going to keep the skeletal up, but I'm just going to go ahead and close that and that. We'll keep the skeletal up. All right, so we've updated updated the vehicle that we want to use. We've gone ahead and created our new mappings. The next thing I'm going to do is I'm actually going to go ahead and prep this HUD. So for drone, we needed, so this is our drone HUD, and as you can see, we actually have two of these, and one of them is the total, maps the total thrust, and the other one is the actual collective, which is what we actually need to play with. Since we're going, and this works well for Z-axis, but we're on the X-axis, so what I'm going to do is I'm going to copy this, and I'm going to go and make a couple of changes, kind of scale it back a little bit, so that we can use it for vehicles which are moving along the X-axis versus the Z-axis. So to do that, I'm just going to go back into the content drawer. I'm going to right-click, and I'm going to say duplicate, and instead of drone HUD, I'm going to call this jet HUD. All right, so now that we've got that, we've got the jet HUD, and I'm just going to go ahead and remove this, delete that, and I'm going to delete that. So everything else is going to stay. I can probably just bring this in a little bit. Hit save. And then I'm going to make one more change, and that change is going to be in the function for the throttle percent. So back when we were doing the helicopter, right, when we created we created the drone HUD, but what we did is we went and moved, instead of using the actual drone, we're actually using this interface. So we go on to owning pawn, we cast it to the interface, and by casting it to the interface, if it succeeds, then this HUD can be used with the vehicle. So if this vehicle has this interface on it, we can then get access to these two extra functions that is on that vehicle, and then we will be able to get access to the component in the actor. So that's there. We don't need to change anything there. The only thing I want to change is actually on the throttle, and all I want to do is I want to take that out, and I want to map this to the X instead. And hit save. So okay, so this is actually nope, I'm going to delete this function, and we want to use this one instead. Two functions. All right, there we go. That one's better. This is the total thrust percent. That's the one I actually wanted. So we deleted that function. We only have so we've cleaned this up now. This is set to jet. We've got our bone. We've got this. All right. So now that we've got all of the other stuff, all of this small stuff out of the way, let's go and set up our vehicle. All right. So to do that, I am going to go into the content drawer. I'm going to go up to our blueprints, and I'm going in here, I'm going to go right click, and I'm going to say new blueprints. We want a pawn blueprint, and I'm going to say BP underscore, and this is going to be what? Jet. Something real original. Alright, so now that we got this, let's go ahead and set this up. First thing I'm going to do is I'm going to go into the class settings, and under class settings we're going to go to interface, and I'm going to go ahead and add our BPI. This is the heli HUD. It'll work for us as well. So this is our vehicle HUD. And what that does is and once we inherit BPI heli HUD, this should get us the get actor and then the get simulated component. So we can still use that same interface. I'd probably rename it to something a little bit more generic at this point, but we'll keep it. Alright, so next I'm just going to go ahead and add the vehicle simulation component, since we're going to need this. And what I'm going to do, I'm just going to compile. Let's go ahead and just get these interface functions out of the way. So I'm going to pop up get actor. I'm going to drag off here and say self. So this is going to reference ourself. So our HUD is, one, it needs the actor for some actor information, and it also needs access to our component. So here's our simulated component. I'm just going to drag this off, and we'll just drag that in there. Compile, save. Alright, so that should do it for the interface. So I'm just going to close that since we don't need to be back there. So let's go ahead and set up or get all the settings done. So we'll set this all up. So I'm going to start off with getting the skeletal mesh done first. So there's our skeletal mesh. We need to make this a root component. So on the skeletal mesh, I'm going to say use our Typhoon Fighter. And then under the animation class, we should have a Typhoon, here it is, BPA. That should be the animation engine. Let's just double check real quick. There it is. Yep. So yeah, little blueprint animation. That's what that is. Or I think the convention is animation blueprint. But okay, we can roll with that. So that's the blueprint. That's the animation blueprint. That's the skeletal. So then the only thing we need to now do is go ahead and set up our physics. So I'm going to go ahead and set this to simulate physics. And linear dampening and angular dampening are fine. Any constraints, gravity index is fine. Update kinematics from simulation. I'm just going to turn this on for now. The system will automatically turn it on anyway. Disable rigid body. That's okay. Okay. And then collisions. So with collision, we want to turn, I'm going to turn this to vehicle. So it's going to use the vehicle collision. Everything else should be okay. Alright, so that should do it for our skeletal. So let's go ahead and set up the camera. So to do that, I'll get into spring arm. So here's our spring arm. And for the spring arm, let's go ahead and I'm going to go ahead and connect the spring arm to the center of gravity joint. So there it is, COG joint. So, and then I'm going to set this to 1500, and I'm going to set the Z to 300. So let's go ahead. I'm going to bring open the viewport real quick. So there's our plane, there's our spring arm, it's attached to the center of gravity. As far as the any camera settings, pitch, roll, and yaw, yes, we're going to go ahead and inherit from that. And then as far as lag, I'm going to turn lag on, and I'm going to turn it for rotation lag as well. And I'm just going to set this to 5. I don't need a nice big lag. I just want just enough. Alright, so that is everything there. Let's go ahead and add the camera. And there's the camera. Compile, save, and we're good to go. Alright, so the only other thing I'm going to add here is the afterburner effects. So this particular shape came with some nice little afterburner effects. So let's go ahead and add that. And so I'm going to select the skeletal mesh. I'm going to say add. We're going to find the Niagara Particle Systems component. So this is the component that we want to use. That's going to be running that for us. So in order to do this, I'm going to say, let's rename. I'm going to rename this. So let's just rename. I'm going to rename it Afterburner right. And here I'm going to go ahead and find the RT underscore thrust joint. So I'm going to map that to the right thrust joint. And let's go ahead and find that. So I think it is using the NS Typhoon jet. Not too descriptive, but I think that's the one. Yep, that's the one we want. So that's the afterburner for the left side. So let's also go ahead and get the afterburner on the right side. So to do that, I'm just going to go ahead up to the afterburner. I'm going to say duplicate. I'm going to say L instead of R. And as far as the parent socket, I'm going to find the LT. Should be LT. Oh, LF. So LF. Here we are. LF. Thrust. There we are. So left thrust joint. So now we have both afterburners mapped to their respective joints. So that's where they're going to be. Just going to hit save. Alright, so as far as the setup, I think we're good. There's nothing else we need to do here. So now I think we're just going to go ahead and move into the component and start setting up the values for all of the pieces that are going to make this vehicle move. So let's go ahead and get started on that real quick. Okay, so first let's start with the environmental simulation and go into fluid dynamics. So in our fluid system we already have two fluid systems set up. We have one for air and one for water. We only need air, and I'm just going to go ahead and just use the setting right up here. If you wanted to, you could go ahead and create a curve based on the density and altitude. But for now, for this, I'm just going to go ahead and just use the value as is. So next, let's go ahead and set up a profile. So I'm going to set the current medium to medium 1, which is our air, and we need to set up a profile. And I'm going to set this profile to, again, medium 1. All right, so in order to do this, we need some dimensions, and these dimensions are in centimeters. So I did a little research on the Typhoon, and these were kind of like the rough numbers that I was able to get. So I'm just going to kind of copy and paste them in. So this, and so again, you know, we have the dimensions for moving in the X direction, which is up here, moving forward, sideways, left and right, and then up and down, up and down. Yeah, so this is on the Z-axis, So we have x-axis, y-axis, and z-axis. So these are the numbers. And as far as the drag coefficient, I'm going to set this to 0.5, and I'm going to set this to 0, since I want my wings to do all the lifting for me. I'm going to set this to 3, and I'm going to set that to 0, and I'm going to set this to 3, and I'm going to set this to 0 as well. All right, so that should be the fluid system for us. So this is the environment pushing back on our vehicle. So as we get faster, Newton's third law says that if there's an environment, the environment's now going to then start pushing back on us. And so this is what's going to keep us in check, and this is what's going to prevent us from having infinite speed. So let's close this up. So that's the fluid system done. All right, so next, let's go ahead and do our thrust, and we can do 2 things here. I'm going to start off with static, and I'm going to put 2 static thrusters, 1 for each engine. And so it's on the x-axis, thrust directions on the x-axis. I'm not going to use any offsets, and as far as direction, there's no negation. All right, for thrust point, so I'm going to use this for the left engine. So thrust point, so this is the point of location. I'm going to set the thrust point to the left joint. And as far as an offset, I'm going to do 2 things. I'm going to add a z offset, and I'm going to add an x offset. So I'm actually going to have this come up into the engine a little bit, just a tad. It's just, where I'd like to put it. But this offset is pretty big, and the reason why I've got this offset is because, again, we have this root bone. And so what's going to happen is when we attach to the physics system, right, that root bone is going to attach itself to the physics particle. But what we really want is the center of gravity to attach to the physics particle. And realistically, that's where we want this. That's where we want everything to be. And so, because we have this root bone, and this root bone is about, if I was come up to details, 208 units up off the ground, right? I'm just going to go ahead and have to counter that out, so that this aircraft will fly correctly, based on where we put our points. So again, if you're working with an animation team and you want to use physics movement, when they create it, make sure that they just don't put a root bone in there, and once it's going to look like this when you bring it in, right? But that's okay, because when you're simulating physics and the collision system's on, it's going to keep it up off the ground. But we want to make sure that our center of gravity is in the right place. So I'm just going to go edit. I'm just going to undo that real quick so we pop it back. But yeah, so for all of these for all of our calculations on position, I need to just cancel out that root bone. So we're going to come back. So that's what we've done here, and I'm going to do the same for this as well. And I'm just going to do this here. And instead of the left, this one's just going to be right. So that's left, that's right. There's the offsets. Everything's good to go there. Just can hit save. And then we need some force to actually move our jet. So for force, for both engines, I'm just going to use 25,000, and I'm going to put a 100 thrust multiplier on there. And that should do it. All right, so that's our static thruster setup. If you wanted to have some fun a little bit later on, you could also do gimbal. And so we'll set up the gimbals, but I'm just going to turn the gimbals off initially. So, and the gimbals are it's a very similar setup, right? To as far as position and everything else. The only difference is going to be when we put in the pitch and the roll. So to do that, if you want to use gimbal, so you want to use a thrust vectored plane. Again, the thrust points. So first one, this is going to be left. And thrust point, again, same idea, left. Just going to put that in there, and I'm just going to take this variable and put that in there. And as far as the thrust is concerned, same idea. 25 at 100 for a multiplier. The only difference is going to be when we work with, we're going to use pitch and yaw. So with the helicopter, when we're going in the z direction, on the z-axis, right, going up and down, we used pitch and roll. But for an airplane going in the x-axis, we actually just need the pitch and the yaw. We don't need that. So I'm going to set this to pitch, and I'm going to set this to yaw. So when I give it some rudder, it's going to it would also turn the engine. If I give it some elevator, it's going to turn the engine. And I'm going to use 5 on pitch, and I'm going to use 2 angle on the yaw. So it'll be a more aggressive pitch, vectoring on the pitch. It'll be less aggressive if we put any yaw in there. And again, you don't have to use yaw if all your aircraft needs is just a more aggressive roll and pitch. Then you just roll into it. You can roll in and then just pitch in. You'll just use a vector on the pitch. But if you do want to have some yaw in there too, you could do that. So I'm just going to add a little bit on the yaw. And this, I'm actually going to then set to actually negate the pitch. Don't need to negate the yaw, I think, but we do need to negate the pitch. Since the tail rudder is in the same on the same side as the center of gravity, we should be good there. It's only the pitch because we're now pitching in the back of the center, behind the center of gravity, as well as pitching in the front of the center of gravity. If both the plane and if the elevator and the engines were on the same side, you wouldn't need to negate out. But because we need to negate it to make sure that we get they go in the right. The forces are going in the right direction to kind of give us a more aggressive pitch. All right, so again, I'm just going to turn these off for now. And so that's setting up the left one, and we can then set up the right one to do the same thing. So let's just go and get my thrust point. Again, 50 and negative 208. Along the x-axis, thrust again, we want to make sure that we're using the right number. So again, 25, 100. No curve, so we're good there. And again, pitch is going to be negated, tied into the pitch control, and I'm going to set this to 5. I need to put 5 there, right? Yep. So that's 5, and then I'm just going to set that to 2. Doesn't need to be negated. Or shouldn't be negated. All right, so that should set that up. Alright, so that's our thrusters set up. So now we're going to come down to our new systems, which is our foil and our control surfaces. Alright, so let's start off with the foils. So these are our wings. So the first one, I'm just going to go ahead, just pop two. So this is going to be our left wing and our right wing. So I'm going to have left wing here. This is enabled. I'm just going to go ahead and set up the basic information first, since they're going to be roughly the same for each one. So for shape, right now we can leave that. Let's just focus on the force point. So I'm going to be taking the force point. I'm going to be using the center of gravity as the initial point to make our calculations, and then I'm actually going to move this a little bit further back, offset, and put the lift back there on the, a little bit further back than the center of gravity. And again, we need to cancel out that root bone, so I'm just going to go cancel out the root bone like that. I've got vertical, that. Let's just go ahead and do the same thing, set up the force point here. So again, I'm going to be using the center of gravity. Alright, so I'm just going to do this. I'm just going to do this real quick. Alright, so the only real difference here between the left wing and the right wing is going to be on the y-axis. So I'm going to move the left wing out by 75, negative 75, and the right wing is going to be positive 75. So that should balance out the lift points on those aircraft. This is, again, this is arbitrary. These are numbers that worked for me, but again, you might want to tweak it to your liking. But again, so that is our force points. So now we just need to set up our four configurations. So because so our wing system can have multiple setups. So let's go ahead and set up the first setup. So this is our wing in the up position. So 0 is actually going to be our up position. So this is going to be kind of like our flight optimal wing. So I'm going to set 25 and 25. It's going to have a camber of 2. And I'm going to give it a stall angle of 20. So the stall angle is similar to the max control surface angle that I'm using in the control surfaces. No pitch, no yaw offsets for these wings, and the multipliers are going to stay the same. So that's pretty much our wing in our most optimal state for flight. So now I'm just going to go ahead and add another one for our wing in our when the flaps are down. So again, so for this one, the wing shape is going to be roughly the same. Some aircraft, when you extend the flaps, you actually make the wing larger. Again, it all depends on the flap system that you're using. So again, that's why I kind of wanted to break these out so you can kind of cover your bases. I'm going to make that 20. I'm going to make this 20. So that's the stall angle again. It's based on the control surface stall angles. And then pitch and roll, we're going to keep that the same. Lift multiplier, I'm going to make it a little bit more lifty. And I'm going to make it a lot more draggy. So I'm going to multiply the drag by 6 and the lift by 2. So that should definitely alter the flight characteristics when we bring the flaps down. And again, these are just arbitrary numbers. If you want to kind of dial it in, you're more than welcome to. All right, so everything else should be the same, and that should be, so that's our wing stabilizers. So now we need to do our fin stabilizer. So to do that, I'm just going to hit the add. So to do, we're going to add in our fin. It's going to lots and lots of data. It's enabled. I'm going to just go ahead and set the force point. So I'm just going to set this to the rear rudder joint. So the rear rudder joint is is kind of like along the 1/3 of the way in from the back, and halfway up the fin. So that's where I'm going to put that for now. If you want to put it in and give it a bit more offset, you can. Like everything else, we've got to take that out. Just make sure we did that for these as well. Yep. So I'm just going to take the root bone out. As far as the foil shape is concerned, we only need one. It's not variable, and let's make sure this is horizontal. So we're going to switch this into horizontal mode. And so for a tail fin, I'm going to go with area of 10, camber of 0, since we don't want to favor one side over the other. Stall angle is going to be of 60. That will allow our horizontal stabilizer to give us the maximum turn in there. But again, you can play with these numbers between the rudder and the horizontal stabilizer. And then I'm going to give it a drag of 2. So it's going to have a little bit more drag in there, but I'm going to give, and we'll keep the lift multiplier at 1. And it's set to horizontal. Alright, so that should be it for our horizontal component. So we've got our vertical wings and we've got a horizontal fin set up. So let's go and set up the control surfaces. Okay, so we're going to start with the rudder. So I'm just going to go and collapse the static thrusters, gimbal thrusters, and foils. So we actually have 5 flight control surfaces. We have 2 for the rudder, or 1 for the rudder, 2 for the ailerons, and 2 for the elevators. So I'm going to start with the rudder first. So by default, rudder is set up. So this is going to be our rudder. As far as force point, this is the joint socket, or the joint that is going to be used again. So I'm getting, if you want to know where I'm getting these from, I'm getting from the skeletal down here. So if you want to find it, you can just click on what you're looking for. So we kind of come over here and see where we're getting it. So that's the aileron, right? And then all I'm doing is just right click and just say copy bone name, and you can copy it to the clipboard and then just paste it into your bone socket name here, and we'll do the component will do the mapping. And again, I need to take that root bone out. So normalize everything to the root bone. So I'm going to set the control, so I'm going to set this to 5. I'm going to set the camber to 0, and max control I'm going to set to 60. So this rear rudder can move, has a lot of maneuverability between positive 60 and negative 60. Lift multiplier is going to be set to 3, so when it's moving, it will give us, it will give us a lot more lift to kind of push us around. And I'm going to set the drag multiplier to 2, so as we do it, it's also going to start pushing back a little bit. Pitch angle and yaw angle is going straight up, so we'll just leave it. There's no offset there, and we'll give it 100% condition. So that should be it for this system, and that's the rudder. So the next is going to be our elevators, and we have 2 of those. So I'm just going to go ahead and go 1 and 2. Just going to bring both of these up. So for the rudder, I'm going to switch these both to elevators. And so we have a left side and a right side. So the elevators are kind of up here at the front of the plane underneath the canopy. I'm eyeballing it as a 6 for the area. And I'm going to give it 0 camber. I'm going to keep its control angle as 20. I'm going to keep the lift and drag as 1:1. And I am going to set the yaw angle to -10. So I'm going to slightly bend them out because these canards are kind of slightly bent down. So dun 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 dun. Dun dun dun. Is there anything else I need as far as the variables? No, I think we're good. So all we need to know is we just need the location. So for the left one, it's going to be on the left joint. And the right one is going to be on the right joint. So I'm just going to use the same. And then once again, just like we did for everything else that we're doing here, we need to kind of take that root bones location out. So let's go ahead and do that. Everything else can stay the same. So that gets our yaw and our pitch. So now we just need our roll. And so roll is going to be done through the ailerons. So again, we need 2 of them. So I'm just going to open these up. We've got aileron and aileron. Oops, before we get started on the ailerons, I just noticed something when I was just double checking on my my data here. On the so let's go back to the elevators real quick. So on the elevators and the offset of the elevators, I'm actually going to move them back a little bit. So the front is here. I'm going to move it back just a hair, and I need to move it out just a hair as well. So I'm going to move the left elevator is going to be moved out. Well, that should be negative, and this one should be positive since it's going in the right direction. So, all right, yep, I just wanted to add these extra values. So I wanted to move it back a little bit and move it out a little bit. Otherwise, it would be right on the joint, which is right next to the canopy. So I just moved it back a little bit out onto the stabilizer. So, all right, so, okay, that should do it for our elevators. Now let's go back to our ailerons. So for the ailerons, again, just more data. Let's go ahead and get the locations done first. So for the ailerons, so what I'm going to do is I'm going to take it on. So this model actually has 2 joints. It has one for this, and this is the flaps, and these are the ailerons. So I'm actually going to be using the bones which are on the outside of the aircraft. So I'm going to just take the aileron as is. There's no other modification that needs to be done there, and I'm just going to go ahead and just put the offset there. And then for right, again, I'm just going to go ahead and put that in here. And again, that root bone offset, I'm just going to put that in there. All right, so and I'm just going to go ahead and just put that up there just for naming. Left and right. Okie doke. So that should do it for everything for the offsets. let's take a look at the actual numbers. So for the numbers, I'm using 8 for the area. Again, just eyeballing it. I'm going to use 20 for the max control. And everything else I'm just going to leave the same. It's just really the area I'm just going to set. Alright, so that should do it for our rudder. Let's just double check. Everything looks good there. Our elevator on the left side. Looks good. Elevator on the right side. Looks good. Aileron left and aileron right. Alrighty, so then now that we've got all of that set up, let's just go ahead and finally set up our throttle input. So throttle's going to be on the X throttle system. So I'm just going to open this up. I'm just going to use a 6 rise and a 2 fall. So that's my rise to fall ratio. And then I'm going to turn on enable throttle control, and I'm actually going to set this to 10% for both of these, and I'm just going to set this to, yeah, actually I'm just going to leave this. So this is a 2 and a 1 interpolation, so we'll keep that. I'm just going to enable a throttle and set the ratio. As far as the pitch, roll, and yaw, I'm just going to keep these even for this simulation. And we're not going to need anything for rotation control at all, so I'm just going to leave that all turned off. Alright, so I'm just going to save that. Alright, so I was originally going to do this as just a 2-part series, but I think it's almost pushing 1 hour on the video here. So what I'm going to do is I'm going to go ahead and stop recording, and we'll pick this up again in part 3. Where we'll go ahead and go into the blueprint and set up all of the events so that we can get the animations working on the aircraft, as well as the throttle systems so that we can fly it. Alright, so once again, if you like what I'm doing, feel free to share my videos as well as subscribe to my channel, and I'll see you again hopefully in part 3, where we can get this plane looking like a real plane and fly it around. Cheers. Bye.